on this section 7.6, it's like you already have the skills to do this. That's why there's not even any separate notes for this. On this video, I'm going to end up doing the even ones, and on the other video, I'll do the odd ones. So we're solving equations or inequalities, and we already know how to solve equations or inequalities. We want to get that x by itself on one side. And we should all know that if you have a logarithm that you want to get rid of, you raise both sides of your equation, become the powers of the base of your choice. Or if you have x in an exponent position, you're going to apply a what? A log with the base of your choice, right? So we already know all these. We already have all the tools. There's really nothing to teach here. If we look at number 8, you see, they want us to solve for x, but x is an exponent. So I don't want it to be an exponent. I want it to be a regular x. So I need to make this 2 disappear so that the x could come down. So how do I get rid of this exponent situation? By applying log base 2. So I know it's kind of sloppy, but I'm just going to write it right here. Log base 2 of 2 to the x. That will cause it to cancel out. And over here, I'm also going to do log base 2 of 25. So yeah, log base 2 of 2, that cancels out. X comes down. You have an inequality that's less than. And we have log base 2 of 25. And believe it or not, that's our answer. However, the instructions say round to the nearest 10,000ths. So they actually want us to. Now, when I was in high school, it would be more work because I'd have to use the change of base formula to actually get it into my calculator because it only did common logs or natural logs. You guys have the Casio. Casio is beautiful because it has this button right here. Log base blank of blank. So if you hit that button, this guy right here, log base blank of blank, you should see the spots. And you just type in the 2 right there, type in the 25, and there's your answer. Log base 2 of 25 is 4.64385619. And what does it tell us to do? Round to the what position? 10,000ths. All right, so we have tenths, hundredths, thousandths, 10,000ths. So we technically need to look at the next number to see if that one stays or it goes up. So let me do this. This is our answer, but the 5 is going to make that 8 change to a 9, right? If it's 5, 6, 7, 8, or 9, it'll change the previous to go up. If it's a 4, 3, 2, 1, or 0, it stays. So our answer for this problem will be x is less than 4.6439. Okay? Easy, right? And there will be, well, pretty much half of the quiz is coming from this worksheet, this easy worksheet. You have to use the calculator, especially because the Casio does the change of base formula for you. All you do is type it in. Let's do the next one, number 10. So what would I do here? Log base of 6, right? Log base 6 of that 6 to the z power, and we do to one side, do to the other, log base 6. So this will eliminate. You'll have z equals log base 6 of 45.6. And of course, you just use the calculator. So we have 2 equals 2.1319. And of course, the other number was a 3, which did not change that, so it stays. And that is your answer. And of course, the answers are on the back of the worksheet. Number 12, what would I do? Apply what? Log base 3.5 of that 3.5, so it'll eliminate. So you're going to have x equals log base 3.5 of that 47.9. So on the calculator, hit that log, that empty log button where you could plug in the 3.5 in the base. I'm doing that right now as I speak. And the 47.9 in the parentheses, hit equal, and you will get the answer 3.008. No, I'm sorry, not 3.008, 3.0884. 6, which changes a 4 to a 5. So that gets changed to a 5. So final answer is x equals 3.0885. Whoa, what happened? Jumping to number 14, they're obviously not all as boring as that one. Right here, we're going to apply a log base 2 on both sides. Log base 2, log base 2. So yeah, log base 2 eliminates. The b plus 1, that's an exponent, now comes down as a regular b plus 1. It's less than or equal to, and we need to actually calculate log base 2 of 7.31. And once again, use that calculator, hit that log base, wow, that's a disgusting button. Blank log button, type in the 2 right there, the 7.31. So that 7 will change that 8 to a 9. And let's keep in mind that that is only the right side of this inequality. So we have b plus 1 is less than or equal to 2.8699. And we still need to subtract 1 from both of those. So your final answer will be b is less than or equal to 1.8699. That should be the answer that you have on the back of your worksheet. Moving on, number 16. Where is it at? Here you go. So let's apply log base 2 to both sides. Log base 2 will make that disappear. Log base 2 will change that to a nasty decimal. So this whole thing could be done on your calculator. I do want to see the work though, where this cancels out. You end up with a minus 4 equals, type in log base 2 of 82.1 on the calculator and you will get 6.3593. The next number is a 1, so it's not going to change the 3. Anyway, we still need to add 4, and you could even do that on the calculator as well. Just put plus 4 onto your answer, and your final answer should be a equals 10.3593. So are we learning anything new on this lesson? The truth is no. The only thing that you're doing different is that you're actually using the calculator to get 4 decimal places out, right? So are we cool with having these questions on the quiz tomorrow? Yes. I mean, technically these are even easier than any other. The other ones that are, the ones that are more challenging are the ones that we've been spending on days, these past 3 days of condensing to be able to solve logarithms, right? So half of the quiz is very challenging, the other half is easy like this. What log do I apply on this one? 5. Log base 5. So this will cancel out. You'll have a w plus 3 equals log base 5 of 17. And if you wanted to, you could actually keep going right here. Subtract 3, and this is your answer. W equals this stuff, right? So you could type it into your calculator. Let me try it all at once. Log base 5 of 17. And then on the outside of the parentheses, I'm going to put minus 3. Let me take a picture of this. So check it out, guys. You could type in the whole thing in your calculator, but again, I want to see that work. I want to see this written out right there. Type this whole thing out in the calculator. It'll give you that final answer. And we do want 4 decimal places out. So 1, 2, 3, 4. This 2 does not change the 6. So this is your answer. Number 18, W equals negative 1.2396. Moving on. Gets a little more interesting on this one. We're going to apply a log base 5. That will cancel it out. The 5, that is. What you do to one side, you must do to the other. Apply log base 5 right there. So this cancels out. We end up with the x squared minus 3. That used to be an exponent. Now it's a regular x squared minus 3 equals, we're going to have a crazy decimal right here on the calculator. Log base 5 of 72 equals 2.6572. And if you have your calculator out and you still have that value, 2.6572, all you got to do is add 3, hit plus 3, and it'll give you 5.6572. and that's because I added 3 here and added 3 over here. So what we have now is x squared equals that 5.6572. So let's square root it and square root it. And again, the calculator does it all. Square root of 5.6572, hit equals, get your final answer. X equals plus or minus, because when you apply a square root in an equation, it's both positive and negative, 2.3785. So that should be the answer that you have.